Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
So how do we integrate hyperbolic functions? From the differentiation formula just now, we can deduce that integrate cos ax dx equals to 1 over a sin ax plus c, and integrate sin ax dx equals to 1 over a cos ax plus c. And finally, integrate sec squared ax dx equals to 1 over a then ax plus c. For example, we want to find the integrate of 2 sin 4x plus 9 sec squared 3x dx. Splitting the given integral into two parts, we obtain integrate 2 sin 4x dx plus integrate 9 sec squared 3x dx. And using the formula just now, it equals to 2 over 4 cos 4x plus 9 over 3 then 3x plus c, and simplifies to 1 over 2 cos 4x plus 3 then 3x plus c. Let us now look at how to solve the equation 2 cos squared x minus sin x equals to 3. Using the identity cos squared x minus sin squared x equals to 1, we obtain 2 times 1 plus sin squared x minus sin x minus 3 equals to 0, which simplifies to 2 sin squared x minus sin x minus 1 equals to 0. We now factorize this to obtain 2 sin x plus 1 times sin x minus 1 equals to 0. So sin x equals to 1 or negative 1 over 2. And hence x, using your calculator, you will have 0.8814 or negative 0.4812. The inverse hyperbolic function, inverse cos x, inverse sin x, and inverse then x can all be expressed as logarithmic function. To express inverse cos x as a logarithmic function, let inverse cos x equals to y. We then have x equals to cos y. And then we convert the cos y into 1 over 2 e to the y plus e to the minus y. Multiplying throughout by 2 e to the y, we obtain 2x e to the y equals to e to the 2y plus 1. And rearranging it, we have a quadratic equation. And we solve it, so e to the y equals to 2x plus minus square root 4x squared minus 4 over 2. And hence e to the y equals to x plus minus square root x squared minus 1. Taking the logarithms of both sides, we obtain y equals to ln x plus minus square root x squared minus 1, where y equals to inverse cos x. Let us now look at how to express inverse sin x as a logarithmic function. So again, we let y equals to inverse sine x. We then have x equals to sine y, which is 1 over 2 e to the y minus e to the minus y. Multiplying throughout by 2e to the y, we obtain 2x e to the y equals to e to the 2y minus 1. Rearranging it, we obtain a quadratic function, and we can solve it and obtain e to the y equals to 2x plus minus square root 4x squared plus 4 over 2. And so e to the y equals to x plus minus square root x squared plus 1. Taking the logarithms of both sides, we obtain y equals to ln x plus minus square root x squared plus 1, where y equals to inverse sine x. To express inverse then x as a logarithmic function, again we let y equals to then x, and we then have x equals to then y, which equals to sine y over cos y. And so we have x equals to 1 over 2 times e to the y minus e to the minus y over 1 over 2 times e to the y plus e to the minus y. Then we cancel out the 1 over 2 and express e to the 2y with respect to x. So y equals to 1 over 2 ln 1 plus x over 1 minus x, where y equals to inverse then x. To differentiate inverse hyperbolic functions, let us first look at inverse sine x. So we have y equals to inverse sine x, therefore sine y equals to x. Differentiating sine y equals to x, we obtain cos y dy dx equals to 1. So dy dx equals to 1 over cos y, which equals to 1 over square root 1 plus sine squared y. And we know that sine y is x, so it equals to 1 over square root 1 plus x squared, which gives d dx inverse sine x equals to 1 over square root 1 plus x squared. And so if you want to integrate 1 over square root 1 plus x squared, we will obtain inverse sine x plus c. For inverse cos x, we have y equals to inverse cos x. Therefore, cos y equals to x. Differentiating cos y equals to x, we obtain sine y dy dx equals to 1. dy dx equals to 1 over sine y, and sine y is the square root of cos squared y minus 1. And we replace cos y with x, so we have 1 over square root x squared minus 1. So d dx inverse cos x equals to 1 over square root x squared minus 1. And integrate 1 over x squared minus 1, the square root of it, equals to the inverse of cos x plus c. For inverse then x, we have y equals to inverse then x over a, therefore then y equals to x over a. Differentiating then y equals to x over a, we obtain sec squared y dy dx equals to 1 over a. So dy dx equals to 1 over a times sec square y, which equals to 1 over a times 1 minus then square y, using the identity, which gives dy dx equals to 1 over a times 1 minus x over a squared, and simplifying them equals to a over a squared minus x squared. So we have d dx inverse then x over a equals to a over a squared minus x squared. From which it follows that integrating 1 over a squared minus x squared equals to 1 over a inverse then x over a plus c. So we now want to integrate the inverse of sin x over 3 using the fact that d dx inverse sin x over a equals to 1 over square root a squared plus x squared. We have d dx sin inverse x over 3 equals to 1 over square root of 3 squared plus x squared, which is 9 plus x squared. Next, we want to integrate 1 over square root of 4 plus x squared. And we can see that the formula 1 over a squared plus x squared can be applied here. So integrate 1 over square root of 4 plus x squared dx equals to the inverse of sin x over 2. And plugging it the boundaries 0 and 2, we obtain inverse of sin 1 minus inverse of sin 0. And inverse of sin 1 in its logarithmic form, it is ln 1 plus root 2. Now we want to find the integral of 1 over square root x squared minus 9. So we can recognize this is 1 over square root of x squared minus a squared. So we apply the formula and we have the inverse of cos x over 3, and then we plug in the boundaries 3 and 6. We have inverse of cos 2 minus inverse of cos 1, and express them in logarithmic form. We have ln 2 plus root 3, and that is our answer. Next, we want to find the integral of 1 over square root of 4x squared minus 8x minus 16. Before integrate, we must complete the square as with inverse trigonometric function and reduce the coefficient of x squared to unity. Hence we have the square root of 4x squared minus 8x minus 16 equals to 2 times the square root of x minus 1 squared minus 5, which gives 1 over square root of 4x squared minus 8x minus 16 dx equals to 1 over 2 integrate 1 over square root of x minus 1 squared minus 5. And then we can apply the formula since it is the square root of a squared minus x squared. And so we have 1 over 2, the inverse of cos x minus 1 over root 5 plus c. And express it in terms of logarithmic form, we have 1 over 2 ln x minus 1 over root 5 plus the square root of x minus 1 squared over root 5 minus 1 plus c. And then further simplifying them, we will eventually obtain 1 over 2 ln square root of x squared minus 2x minus 4 plus x minus 1 plus c prime, which is a constant.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.